Good morning, everyone. I hope you had a fantastic week so far. Today, Friday, the 29th of April, 2022, we have a new topic: angles measured in degrees and radian in a unit circle. First of all, we need to know what's the benefit. The object is angle measures in degrees and radian. We use this in Math 237's application of this in Math 237, especially in electrical circuits. And the benefit of this, to find the trigonometric ratios, to find the values of trigonometric ratios in electrical circuits when the power supply is an alternative source. Before we start, we have several definitions. We need to focus on them. And even before that, we have to define what's the meaning of the unit circle. The unit circle is a circle with a radius of 1 unit length. So here is the circle. The radius is equal to 1 unit length. And we have this radius, of course, it's between the origin point, which is 0, 0, 0, and the point xy. Xy is the coordinate of this point. This is the unit circle. The definitions we need to explain for you guys before we start, the first one is the rotation angle. So the rotation angle is the angle formed by rotating an initial arm, or actually it is the angle between the initial arm and the terminal arm. So where is the initial arm? The initial arm is always on x-axis, regardless if we are rotating anti-clockwise or clockwise. Initial arm is always on the positive side of x-axis. The terminal arm is going to be between these 2 points. This is the terminal arm. Now the terminal arm, if we rotate anti-clockwise, like the theta here, so the angle is going to be positive. But if we rotate clockwise, like the theta in here, the angle is going to be negative. So basically we have a rotation angle here positive and the rotation angle here is negative. Of course, as I mentioned, the first one is anti-clockwise and the second one is clockwise. So now just mentioning or put my degrees here. The first, I'm starting with 0 degrees. This is 0 degrees. If I rotate anti-clockwise, this is 90 degrees. This is 180 degrees, this is 270, and this is 360. So always the 0 and 360, they are the same. Now, if we rotate this way, if we rotate in a different way, so we're gonna count the 0 as it is, but this is going to be minus 90 if it's a clockwise, and this is going to be minus 180, and this is going to be minus 270, and this is going to be minus 360. Minus 360. This is the rotation angle. The second thing here, guys, we are going to explain what's the meaning of coterminal angles. The coterminal angles, they are angles having the same initial arm and the same terminal arm. So where is that? Let's take an example here. If I start from the initial arm on x-axis and I rotate anti-clockwise with the angle theta, the red one, having the same initial, this is the initial arm and this is the terminal arm. If I rotate clockwise with the other direction, so I'm starting from the same initial arm and I'm ending up with the same terminal arm. So this theta with this theta, they are both coterminal angles. But I can write down another coterminal angles. If I go from the same point here and starting from the initial point and I rotate a whole circle and coming back to the same terminal arm. So this angle with the blue color is another coterminal coterminal angle to the angle theta. Another coterminal angle. So the coterminal angle theta here is negative, while the blue one here is positive and positive, and the red one is positive as well because they are both anti-clockwise. Now, the other thing here, what is the principal angle? The definition of the principal angle is The principal angle of a set of the coterminal angles is the smallest positive angle from the initial arm to the terminal arm, or between the initial arm to the terminal arm. So basically, if I have among all of these three coterminal angles, theta red, theta black, theta blue, the principal angle is this one. It's the theta red here. That's the principal angle because it's the smallest positive angle between the initial arm and the terminal arm. So we finished with this. Now the most important definition among all of them is the last one, which is the reference angle. So what's the reference angle? The reference angle is the angle between the terminal arm and the closest x-axis, and it should be an acute angle. It should be an acute. So we don't care how the rotation is when we count the reference angle. The rotation is not a big deal, but we need to know that the reference angle is always positive and acute angle between the terminal arm and the closest x-axis. Let's take two examples, or actually 4 examples for each quadrant. For the quadrant number 1, we have the rotation angle this way, while the reference angle, because as per the definition, it is from the terminal arm to the initial arm, so it is here, theta reference angle. In the second quadrant, the rotation angle is this one, while the reference angle is between the terminal arm and the closest x-axis, so it's an acute angle. If I do that for the third one, or the third quadrant, so I am going to say that the rotation angle is this, and this is theta rotation. I'm going to write it down here, theta rotation, while my reference angle is between the terminal arm to the closest x-axis. So I can say that this is my reference angle in here. This is my reference angle. For the fourth quadrant, my reference angle will be a little bit different because it's going to be, so if I count the rotation angle, all of this is the rotation angle, R rotation. So my reference angle is going to be between the terminal arm, which is this one, to the closest x-axis. So I can name this angle theta reference angle. So we have reference angle in each quadrant. In quadrant number 1, 2, 3, 4. But to mention, to exactly explain what's the reference angle, we need to use a table. We need to use a table, and I'm going to explain that in this table. So let's write down rotation angle in the first quadrant. In the first quadrant, I'm going to say that the rotation angle itself is equal to the reference angle. And it doesn't matter if it's in degree or in radian, because we are going to explain what's the meaning of radian measure. And for the quadrant number 2, the rotation angle is actually equal to 180 minus the reference angle. For the third quadrant, the rotation angle is equal to 180 plus the reference angle. And for the fourth quadrant, the rotation angle is equal to a 360 minus the reference angle. You may ask me why. Because in the second quadrant, here is 180 degrees. If you check here, this is 180 degrees. Of course, this is 90. This is 270 degrees. And the part here is going to be 360 degrees. So if rotation angle is 180 minus reference angle. 180 minus the reference angle. That's in second quadrant. In the first quadrant, they are both the same. In the third quadrant, the reference angle is 180 plus the reference angle. In the fourth quadrant is 360. You go all the way to the beginning, then you come back by the reference angle. So we have this in here. Now, the reference angle in degrees, and of course I'm going to mention, if I want to convert each of these equations in terms of the like rotation angle in terms of reference angle, here will be the same. I have the reference angle equal to rotation angle, and here I'm going to make the reference angle, just manipulate and say that this is 180 minus rotation angle. Here it's going to stay as it is, so that reference angle in here is equal to rotation angle minus 180 if I move the 180 to the other side, while here the reference angle the reference angle is equal to, I move it to this side, so it's going to be 360 minus the rotation angle. That's the first part. So the second part of this lesson is the measure of the angles in a unit circle, or the measure of the angle in radian in unit circle. So now, if I come to this place and plot the circle for you guys, the beginning, here we have a 0, here is pi over 2, here is a pi, here is a 3 pi over 2, which is 1.5 pi, and here is 2 pi. That's the, if the rotation is anti-clockwise. If the rotation is clockwise, so I have the very beginning here is a 0, and this is minus pi over 2, this is minus pi, and this is minus 3 pi over 2, and this is minus 2 pi. So these are the parts of the unit circle in radian. Before we start, we need to know what's the meaning of angle in radian. Angle in radian, if I make another unit circle here, or plot another unit circle here, this is x-axis and this is y-axis. If I take an angle here, like the angle theta, I'm going to take the angle theta. Between the initial arm and the terminal arm, we said that the terminal arm's point is xy coordinates, and this is the origin, 0 and 0. And this is the radius, which is equal to 1 unit length. Now, if the radian angle, the definition of the radian angle is, if the angle theta is facing an arc, here's the arc. The arc has a length of exactly length of the radius, and it doesn't matter now here in this situation if the radius length is 1 or more. But if the arc has a length of the radius, then theta, according to this, theta is 1 radian angle. So now we need to know how much radian angles we have in a whole circle. You know that the circumference of a circle is equal to a 2 pi r. So the whole circumference of any circle, the circumference of any circle is 2 pi r. If I divide the circumference of any circle by the radius of the circle, so I am going to have, canceling out the r with r, and I'm going to have that there is in each circle I have 2 pi radian angles. 2 pi radian angles. What's the meaning of 2 pi radian angles? We know that the value of pi is 3.14 approximately. So it's a 2 times 3.14, which means 6.28. So in each circle we should have 6.28 radian angles. If this is the first one, and that's the second one, and this is the third one, so we have this small part, 0.14 of the radian angle. And this is the first part, or maybe we can make it a little bit nicer. Here's the first part, here's the second part. Just make it more. And this is the second part, and this is the third one, or actually here. So we have approximately, this is another 0.14 of the radian angle. So in each circle, we have 2 pi of radian angles, which means 2 times 3.14, 6.28 radian angles. That's in each circle. The table we had in the previous class, we had this table in degrees. Now I'm going to fill the table with the same relation between the reference angle and the rotation angle, but in terms of radian. So now for radian, I have the same situation. I have the theta rotation equal to theta reference angle for the first quadrant. And for the second quadrant, I have, instead of each pi, I am going to substitute pi. Instead of each 180, I'm going to substitute pi. So I'm going to say here, the theta rotation is equal to pi minus the reference angle. And here, theta rotation is equal to pi plus reference angle, and here theta rotation is equal to 2 pi minus theta reference angle. Manipulation of this, in this part, I'm going to fill that as well. So I'm going to say that reference angle is equal to the rotation angle in here, no doubt, because it's the first quadrant. The second quadrant, I am going to write down the same situation. Reference angle is equal to a pi minus rotation angle. And in here, I'm going to write down the reference angle is equal to the rotation angle minus pi. And here, I am going to say that the reference angle is 2 pi minus the rotation angle. Now we got the definition of the radian angle, so let's write down the definition actually. The definition is, we just need to mention the definition of the radian angle. Let's write down here. A radian angle is an angle facing an arc length with the same length of the radius. Again, this is the beginning. If we rotate from anti-clockwise, so it's going to be 0, pi over 2, pi, 3 pi over 2, 2 pi, and clockwise is going to be 0, negative pi over 2, negative pi, negative 3 over 3 pi over 2, and negative 2 pi. Now, I would like to finish this, and so I thank you so much for your listening to me and for this lesson and for your time. Thanks a lot.